Today's lesson is on multiplicative inverses of matrices, and one of the most challenging pieces of the lesson will be being able to say multiplicative inverse. So IN, recall from our first lesson on matrix definitions, that IN is called the identity matrix. It's a square matrix with dimensions n by n. So for example, I4 will be this 4 by 4 matrix. It's got ones all along the main diagonal and zeros everywhere else. And so I2, for example, will be this matrix. Okay, and so we can have I3, I4, I5, etc. Property of the identity matrix is that if I take any matrix and multiply it by I get the same matrix. Or if I take I and multiply it by any matrix, I get the same matrix. Okay, and so it's just like multiplying a number by 1. Multiplying a matrix by the identity matrix does not change its values. So for instance, here we have a 2 by 2 matrix, A, and we have I. So let's multiply A by I using our row by column method. If you feel confident to try it on your own, press pause and do that, and then you can check once you hit play again if you're correct. So if I take row 1 and column 1, I'll have negative 3 times 1 plus 6 times 0, so negative 3. And then row 1 and column 2, I've got negative 3 times 0 plus 6 times 1 gives me 6. I'll move down to the second row, first column, I've got 5 and 0. And the last one gives me a 0 and 2. So you can see that the result is the same. So now we'll take I and multiply by A. So we're doing the rows of I by the columns of A. So I've got 1 times negative 3 and 0 times 5 and 1 times 6 plus 0 times 2. Then the second row, I've got 0 times negative 3 and 1 times 5. It's hard to do these when they're backwards to each other. And when I do the final one, I get a 2. So we can see that matrix A multiplied by I and I multiplied by matrix A give us the same result. So this is what we're heading towards here. If A is an n by n square matrix, and there's a matrix that exists such that if I take A and multiply it by A inverse, and I get the identity matrix, and if I take that matrix and multiply it by A and get the identity matrix, then we call A inverse the multiplicative inverse of A. And I'm going to start soon dropping the word multiplicative because it's so long. And we read this term as A inverse, not A to the negative 1. Okay, so we'll read that as A inverse. And when we talk about A inverse in that term, we're talking about the multiplicative inverse of A. So that A inverse times A gives me I, and A times A inverse gives me I. So let's do some checking here. I've got two 2 by 2 matrices here, A and B. And I want to check if B is the inverse of A. So the way I can do that is just to multiply them together and see if I get the identity matrix. And in this case, it'll be a 2 by 2 identity matrix. So again, press pause if you feel comfortable to do that and test the multiplication yourself. I've got positive 2/5 plus 6/10, so that gives me a 1. I've got negative 1/5 plus 2/10, which gives me a 0. I've got negative 6/10, negative 6/5 plus 12/10, which will give me 0. And I've got 3/5 plus 4/10, which will give me 1. And likewise, when I multiply the row and column here, I will get 1, 0, 0, 1. So B is the inverse of A. Here's one for you to try. Show that B is A's inverse, where A is 2, 1, 1, 1, and B is 1, negative 1, negative 1, 2. And so test those out yourself by multiplying, and I will tell you that uh, yes, they are. B is the inverse of A. So you should get 1, 0, 0, 1 when you multiply these together. Remember to use the row by column method. Okay, so how do we find the inverse of a 2 by 2 matrix? Okay, so here's one method that we're going to look at. Okay, so let's say I'm starting with matrix A. It's a 2 by 2 matrix, negative 2, 7, 1, and negative 4. Well, I can just say, well, let's just say that the inverse of A has these 4 elements, A, B, C, and D. Okay, then let's multiply those using the row by column method. Okay, so that'll be at negative 2A plus 7C for that row 1, element 1 of our product. Okay, so now I'm going to do row 1 and column 2, so I have negative 2B plus 7D. Now if I move down to the second row, I've got A minus 4C, and I've got B minus 4D. So there's the result of multiplying those two. But I also know that if I multiply A by A inverse, that equals the identity matrix. So that's equal to 1, 0, 0, 1. If A's inverse is the inverse of matrix A. So now I have this matrix with 4 variables and this matrix with 4 values. I can actually now set up a system of equations, or a couple of systems of equations. Notice that this must now be equal to this. And A minus 4C must be equal to 0. Okay, because this is the result of multiplying, but we also know that if they're inverses, they'll multiply to give me the identity matrix. So I'm going to look at just the first column here for starters and recognize that I have a system of equations where equation 1 is negative 2A plus 7C equals 1, and equation 2 is A minus 4C equals 0. If I look at those two equations, I can then use elimination to eliminate one of the variables, and I'm going to do that to eliminate variable A. So I'm going to take equation 2 and multiply it by 2. So I get 2A minus 8C equals 0. Equation 1, I'll just leave the same. I've got negative 2A plus 7C equals 0. When I add these together, I have negative C equals, and I apologize, that's a 1. So negative C equals 1, so C equals negative 1. I now know one of the values of A's inverse. Okay, if I substitute that into equation 2, I'll get A minus 4 times negative 1 equals 0. So that'll be A plus 4 equals 0, so A will be negative 4. I now have the value for A. I'm going to use the same method now and solve for B and D. So I'm going to take the value that I got for B, so that'll be negative 2B plus 7D equals 0. So now we're looking at the right side column of our result matrix. And I'll call equation 4, that last one, B minus 4D equals 0. So again, this parallels the first two equations, so I'll leave this one the same. And my mistake, this should be a 1 here. And I'm going to multiply this one by 2. So I have 2b minus 8d equals 2. And when I add the two equations together, I'll have negative d equals 2. So d equals negative 2. I'll substitute that into equation 4. So I'll get b minus 4 times negative 2 equals 1. So that'll be b plus 8 equals 1. So b equals negative 7. So what I get for A's inverse then, remember A's inverse is A, B, C, D. I can use the values that I got for A, B, C, and D. So I've got negative 4 for A, for B was negative 7, C was negative 1, and D was negative 2. And I could test this result by multiplying A times A inverse and checking that I got the identity matrix. So a couple of things to note here. I think I have that on the next slide. Yes. So note, only square matrices can have an inverse. Not every matrix has an inverse. And if a matrix does have an inverse, it is unique. That means there's only one possible inverse for any given matrix. Think about why only square matrices can have an inverse, and we'll have a discussion about that in class. Now that was a pretty involved way of finding the inverse of the 2 by 2 matrix, and we're going to look at a shorter method here, and this kind of gives us a formula. So if our original matrix, 2 by 2 matrix, is A, B, C, D, then A's inverse is 1 over A times D minus B times C, so that'll give us a scalar, a real number, times D negative B negative C A. So if you look at this, the way to remember this is you'll need to remember this piece, and what you've done is you've multiplied the major diagonal and subtracted multiplication of the minor diagonal. And then look here, notice that two of the elements have traded places, and that was A and D. So along the major diagonal, those two switched places. And the other two elements just changed signs. So B became negative B and C became negative C. This real number factor at the beginning, 1 over AD minus BC, is called the determinant. And that's going to come through in other lessons as well. We'll see that again. And if AD minus BC does equal 0, so then we would have 1 divided by 0, which we know is not, does not give us a defined result. So if AD minus BC is 0, then A does not have a matrix, an inverse. Okay, so remember, not every matrix has an inverse. So let's do an example of using this formula to find the inverse. So if B is the 2 by 2 matrix, negative 3, negative 5, 1, and 2, to find B's inverse, we'll use the formula. So B's inverse will be 1 over, and it's AD, so negative 3 times 2 minus BC, so it'll be negative 5 times 1 times, and it's D and negative B, so D is 2, negative B will be positive 5, and negative C will give us a negative 1, and A will be a negative 3. So we switch places going along the major diagonal, and we switch signs for the other two elements. So now we can simplify that. If we look at that, our denominator is negative 6 plus 5, so the determinant is negative 1. So negative 1 times 2, 5, -1, -3 will give us now -2, -5, 1, and 3. And this then is the inverse of matrix B. There are ways of finding the inverse of 3 by 3 and 4 by 4 matrices, and you can look at some of them in your textbook, but we'll be in class using technology, and I'll show you with the graphing calculator and the matrix applications how we can use the power of the calculators to find the inverse of 3 by 3 and larger matrices, and we'll do that in class.